Heavenly Father, we come before you today, Lord. Thank you for this day. Thank you for this time, oh Lord, we enter into, Lord. Lord, we pray that you may give us strength in this moment, Lord, to understand all what the teacher is going to share us within this topic, Lord. Lord, may we utilize him to the best of our abilities, Lord. May we not squander this time, Lord. May we use it, Lord, efficiently and effectively, Lord, so that we shall excel in our papers, Lord, that are going to come, Heavenly Father, Lord. To the glory and to the honor of your name, I prayed and believed. Amen.
Thank you so much, Amara, for the word of prayer, and you're most welcome, everyone that is joining this session. According to the poll, I noticed that many of you wanted us to look at vectors first, and those who have done some mock papers, you have noticed that at least 3 mock bodies have said something concerning vectors, meaning that it is still relevant and we need to review it. In our lesson today, we are going to look at vectors, and the few things we are going to look at. One, we shall look at a bit of introduction on what vectors are. We shall look at the addition of vectors, subtraction, what we call position, and what we call the column vectors, finding the unknown vectors, midpoints. Then we shall look at the external and internal divisions of lines. Then we shall look at parallelism. And then lastly, we shall look at what we call collinearity. Now, when we talk about vectors, the first thing we need to know about vectors is that vectors are those quantities that exhibit what we call the magnitude and what we call the direction. These are the two important things when we talk about the vectors. So in vectors, we look at what we call the magnitude and what we call the direction. Now, when we talk about magnitude, here we are talking about the size. We are talking about the weight. We are talking at how big something is. That's what we call the magnitude. Then when we are talking about the direction in vectors, here is where we look at whether it is going to the east, whether it is going to the west, whether it's going to the north, and whether it is going to the south. So at this level, we may look at these 4 directions. But when you advance, we shall go beyond the 4 levels and we can look at more at the 4 directions, and we shall look at the northeast, we shall look at all those directions. Now, in vectors, when you have a line, this line represents what we call the magnitude. It represents the size of the line. Then the arrow, it is what represents our direction. Meaning that whenever you are dealing with vectors, it is always important you put the arrow to show which direction you are taking. Sometimes, let me say this is A and this is B. Always, the first letter here shows you the starting point, and then the last letter shows you the end point. So in vectors, the direction is very important. So when I have my vector A to B, it means that A to B, that I'm starting from A and I'm going to B. Now AB is the magnitude. Then when I put an arrow here, it will show me the direction that I'm starting from A and I'm going towards B. When I write maybe C and D and I put an arrow like this, it means that I'm going to start from C and then I'll go up to D. That's what we call the vectors. So always we represent using the size, and also we look at which direction are we taking. Then when it comes to Cartesian plane, when you are representing them on the Cartesian plane, now it is important now for you to know that on the Cartesian plane, if this is my Cartesian plane, you know this is our x-axis and this is our y-axis. Now along the x-axis, any movement you make, this one is the positive direction. Along the y-axis, this is the positive direction. Along the x-axis, this is negative and this is negative. So whenever you are moving in the positive x-axis, those vectors will be positive. Then when you are moving up, that one is still positive. When you are moving to the left, that is negative. And when you are moving downwards, that is negative. That is when it comes to the direction. So whenever you have a line, let me say this is your line. It means that you're moving in the positive direction. So for whatever steps you are taking, they are going to be in a positive direction. When I'm moving downwards here, downwards is the south. So it means that south is negative. So whatever steps you take downwards, those are going to be the negative steps. So that one you always put the negative to show the direction. So in vectors, positive represents the movement along the positive x-axis or along the y-axis. Then whenever you say negative, a negative means that you're moving in the south direction or you're moving towards the west. So that is the bit of a brief introduction on this kind of on vectors. Then what is important? One, whenever you are representing these vectors, never forget the arrows because the arrows shows you the direction. Then the line will show you the magnitude. Then the different symbols we can use in vectors, when you find capital letters with an arrow, that one will represent a vector. Sometimes they can just write AB and they don't put an arrow, but they put something up here, still that one represents a vector. Sometimes when you are working with a lowercase, they can write it like that with the under accent, or they can write B with under accent. And sometimes they can just bold it. So all those ways, they can write them to represent the vectors. Now, it will depend on which kind of application they are looking at in vectors. Sometimes, in case they are looking at movement or transport, they can put units. So you need to know whether the response you are giving requires units or it does not. Sometimes in case you are dealing with the speed, they may write it in kilometers per hour, or sometimes they can write it in meters per second. So it depends on what you are dealing with. Then also I want us to take note on what we call the column vectors. Now in vectors still we have what we call column vectors. These ones are what you call the rows. Rows run horizontally. Then when I run vertically, those are what we call columns. So in vectors, when we tell you to write in a column form is always in form of X and Y. So always we start with X and then we move along the Y direction. So this is how you represent your column vectors. Hope we are on the same page. Now we are going to start our first activity. When you look at this activity, they are telling us that a boat is heading north from one shore to the other at a constant speed of 4 kilometers per hour. This means that after 1 hour, this boat has covered a distance of 4 kilometers. The water current flows east at a constant speed of 3 kilometers per hour. Then they're asking you, where will the boat actually end up? What will be the actual path of the boat? Now, when you look at our question here, you notice that you need to know where is the boat located, that this is the position where our boat is. And now they're telling that how is it moving? It is moving in the north direction. Now you're going to allow me that every box represents 1 kilometer. What does it mean? When they tell us 4 kilometers per hour, it means that every 1 hour it will be 1 kilometer. So if it is moving the north, it will move, that is 1 kilometer up to this point. These are 2 up to this point. These are 3, and then this is the 4th kilometer. So it means that our boat is somewhere here. Now, if our boat is somewhere here, that is where it has stopped. Then they're telling that the water current flows east at a constant speed of 3 kilometers. That means that when it reaches here, it's going to be carried by the water. So how many kilometers? It will move 3 kilometers. So now it will move. This is 1, this is 2, and this is 3. That means that the position of our boat currently, our boat is going to be here. But since we have said that these are vectors, I'm going to represent them using a line. So I'm going to draw my two lines to show how I'm moving. So the first line I'm going to draw is that north line, showing that now the boat is moving the north. Then I'm going to draw that line going to the east to show the current displacement. Then afterwards, I'll show the actual path that the boat must have taken for it to reach safely in the place. Now, what is important here? One, they want us to find out the vector per hour for the boat is heading. Now, when you look at our boat, this is how our boat is moving. So we have said that when you are writing your vector for the boat heading, we always write it in form of x and y. X is the movement along the x-axis, and then y is the movement along the y-axis. Now, when you look at the movement of our boat, you notice that along the x-axis, it has not made any movements. So along the x-axis, we shall have 0. Then along the y-axis, it is moving up. This is 1 step. These are 2, 3, and 4. But which direction is it taking? It is going upwards. So we say that upwards, that will be always positive. So here I'll have positive and this will be 4. So that will be our vector for the boat is heading. Then when it comes to the current displacement, I'm going to look at how our boat has moved in the east direction. Now, along the east, this is what we call the x-axis. Now, when I'm writing my vector, still I will start with x, I'll end up with the y. Now, along the x-axis, our boat has moved 1, 2, and 3 steps. So it has moved 3 steps, but the direction it has taken is the positive direction. So here we shall have 3. But along the y, it has not made any movement. So our y here is going to be 0. Now that is our second. Then the third one, they're asking us the actual path of the boat. We are asked to find the vector. Now when you look at the vector, you notice that this is the line, this line here. You are noticing the green line here. Now when you look at that line, you are noticing still we need to get the x and we need to look out for the y. But what do we have for our x and y? You notice that our boat moved along the x-axis. It moved 1, 2, 3 steps. So along the x, it will be 3. Then along the y, it moved 1, 2, 3, and then this is the fourth. So along the y, it will be the 4. So now this is how you represent your vectors in a column format and to obtain the actual path. But you notice that what we are looking for is what we call the addition of vectors, meaning that the actual path of the boat could as well be obtained by adding the boat's heading and the current displacement. When you add these two, you can be able to obtain the actual path. Kindly let me know whether we're on the same page in the chat. Okay, 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 okay. So we are going to try one more. Let me put another number and I ask you to try. I want us to read this question, everyone, and then I'm going to ask you to write for me the vector for part 1. Then after, write for me for part 2 and write for me for part 3. I understand in the chat, you may not be able to write them in a column form, but I want you to write them bit horizontally, but I want you to write for me the boat is heading, the current displacement, and the actual path. So I want us to try in the chat. Okay, the part on actual distance. Okay, I'll repeat that. So when you get your bot heading, feel free to place your answer in the chat. Current displacement, place your answer in the chat. And then the actual path, you can place your answer in the chat. So first obtain the vector when the bot is heading east. Then from there, you get the current displacement. Okay, from the chart, people are getting 30. Okay, 30, 30. Okay, 0330. Okay, okay, we can start from there. So they told that the boat is heading east at a constant speed of 3 kilometers per hour. It means that after 1 hour, the boat has covered a distance of 1 kilometer. Now, this is the position where our boat is. So it's going to move 3 kilometers. So now the first kilometer, this is the first one, the first box, the second, and then this is the third. Now that is where our boat is. Then they are telling that the water current flows east at a constant speed of 2 kilometers. So what does it mean? It means that now our boat is going to be carried at a speed of 2 kilometers. Now, for the first one, the boat is heading, like we have said, you're going to look at X and you're going to look at the Y. Along the X, you ask yourselves, how many steps have you moved along the X? That this is one step, this is the second, and this is the third. So along the X, you have moved 3 steps. Then you ask yourself, have you been able to move along the Y? That no. Y means that you are either moving up or down, up or down. So since we have not, our boat has not moved up or down, then that means that along the Y, we shall have 0 as our movement. So those who gave in 30, that was very, very okay. Then from there, we are going to go on and get the current displacement. Now, our current displacement, okay, when you look at my diagram, I'm trying to show you the heading of the boat. Now, this is where the boat is currently. Now, it's going to be carried by the water. So to be carried by the water, I'll add on that. That is the current displacement of the boat. Now, in order for me to get the that is the actual path when you combine the two. So 30 is your answer. Then 20 is what we call the current displacement. And then our actual path, it's going to be always when you are obtaining your actual path, you always count from the starting point up to the finishing point. This is the finishing point and this is where the boat was initially. So when you look at it, you will note that you'll have your answers 5, 0. Then the other alternative bit would have been that in order for you to get the actual path of the boat, you combine the two vectors. You combine the boat's heading and then the current displacement. So you have, let me say this is 30 for the current boat's heading plus the current displacement, which is 2, 0. When you look at the two vectors, you notice that this is what we call addition of vectors. And when we are adding vectors, we add the x component and the x component alone. So here I'll have 3 plus 2. and then I add the y and the y component, which is 0 and 0. So we end up with 5 and 0. So that is the answer you were meant to get. Okay, but I'm saying the answers are correct in the chat. Okay, now we are going to start with the vector geometry. This was brief about vector addition, but now we are going to concentrate on what we call vector geometry. Now, in vector geometry, one of the things we are going to pay attention to is the movement. Like I've told you, direction matters. Or how to state answer for A? A, where will the boat actually end up after 1 hour? What will be the actual path of the boat? Now here, it's mainly this part here. Let me first remove. For part A, when they ask where will the boat actually end up? Now that means you're going to show this on the diagram that they have given you. So this you show it graphically on the diagram. So this is how you show it graphically on the diagram. And then to show the actual path, this is the line you have, like the green line is the actual path. But don't forget to put the arrow. Okay. Hope that is okay. Okay, now we go to the vector geometry. Now this is where we have a lot of applications, and the scenarios that we are going to meet are going to come from this part here of vector geometry. Much as also you can have the other first part, but what is important is you understanding the vector geometry. Now, one thing that is very important is you understanding the path that the vector is taking. Do not cram, but I want you to understand. When you look at our first number, we are going to do the first item. They are telling us that OPT is a triangle. So you notice that this is O, this is P, and this is T. Then the second part, they are telling us that M is the midpoint. When we talk about midpoint, midpoint means the middle. In case I have a line, let me say this is my line. My line is A and this is B. The midpoint means that M is in the middle. And when M is in the middle, it means that M is dividing my line A and B into two equal parts. And whenever something is divided into equal parts, it means that the parts here, this part here, must always be equal to the second part. So if this is my line A and B, and they have told you that M divides it into two equal parts, it means that here I'll have one part and this part must be the same. So this is 1 and this is 1. In case this is 2, also this will be 2. That's what you call dividing something into two equal parts. But the total ratio for the two parts here is going to be now 2, because I'm going to have 1 plus this 1, which will give me a 2. That is the first thing I want us to understand as we dive into our discussion today. But you're going to allow me to first create an empty slide here such that I can first explain further. Now, I am going to continue with the explanation. Now, when we have any vector, let me say this is our vector. This is my O, this is my A, and this is my B. This is my B, this is my direction. In case they have given us that O to B is represented by B and O to A is represented by A. It means that from O to B, we shall write it as OB. That is the vector. The first digit shows us the starting point. Where are you starting from? Then the second digit shows us the end point. O to B means that you have started from O and you have moved towards B. So I can put an arrow up here to show that I'm starting from O and I'm going to B. That means that this vector, when I'm writing it, it is the one that we represent by B. When I write O to A, it means that I'm starting from O, I'm going towards A. And when you look at our vector O to A, the arrow clearly shows you that you are starting from O and you are going towards A. So this vector here, I write it as A, like that. But if the question you are dealing with involves, let me say, when they tell us A to O, A to O means that your starting point is A here. This is the starting point, and this is the end point. It means you have started from A and you are moving towards O. So you are coming like this. What does it mean? It means that you have opposed the initial arrow. Now, to show that you have opposed the initial arrow, always put a negative. That negative shows you that you are moving in the opposite direction to the one of the vector that was given. So A to O will be negative A. Hope that is okay. In the chat, you tell me, what if they have given us BO? How will you represent vector BO? Quickly in the chat. How will you represent vector B to O? Or what will be your response? Good. B to O now will be negative, negative B. Very good. Okay. Yes, Amara, you can unmute.
Yes, teacher, good morning once again.
Money.
Teacher, I want to ask you a question. Now, depending, most
Mm,
especially with the positive vectors and negative vectors. Now, as you are saying, when you're posing the vector they have given us, like let
mm,
me say it was moving downwards. Hmm?
mm.
So again, now, as it's
Let
moving,
me say it was like this. When the arrow was like this.
yes, let's say the arrow is like this.
Mm,
Then now we're opposing it to B or to
mm,
A,
mm,
right? It's moving up.
mm.
We'll be saying we're moving upwards.
Uh-huh.
Teacher, wouldn't
When
it
they tell
be,
you O to A
yeah, if
for
they
this
were to say,
particular diagram.
mm,
Mm,
they were to say O to A.
mm,
Now, in my thinking,
mm.
wouldn't it be a positive real?
Okay.
Because
Now,
remember, you are saying
mm,
that moving downwards, it will become a negative, right?
mm.
Moving upwards, it will become positive, unless I'm confusing something.
Oh, okay. Now there are two things now here we are looking at. Now this one is moving at a diagonal bit of thing. Number two, the arrow determines the direction. So always you look at the arrow. That is the one that tells you where you are heading. Now, this arrow here shows us that the vector going this side has been represented by B. So you don't know by this B. So you follow the initial representation when it comes to vector geometry. The positive and the negative will only work when we are dealing with the Cartesian plane. When you are dealing with the Cartesian plane, those arrows, those vectors you are representing on the graph, then that one will hold. But when it comes to when you are dealing with vector geometry, when you are dealing with the triangles and the rest of that, then always you must first follow the original path that has been given to you. I don't know that that is clear, Mar.
No, it is clear. Just
Mm,
wanted to understand where the positive and negative are played.
okay. Okay. Pauline?
Morning,
Pauline?
teacher. Good morning, teacher.
Morning.
Teacher, I wanted to explain to Amara,
Okay.
like, let me say, in case the arrow, in case they ask us for a direction in the opposite, it must be a negative. But if you're following the arrow, it's always a positive, not so?
Okay.
Thank you,
True.
teacher.
Okay. Yeah, that is true. Yes. So now, in case the diagram was drawn like the way Amara wanted here, then here, A, O, A, your answer here for A to O would have been A. But O to A, since it is opposing, it would have been a negative. Okay, now we are going to start on the first part. They have told us that we have this triangle O, P, and T. M is the midpoint. This is the midpoint. And we have said that for midpoint, it divides our lines into two equal parts. That means that here, this is one part and this is one part. So those two parts are equal. Then they are telling us that O to T is A. You can note the arrow, and T to B is also B. Then they want us to express OM in terms of A and B. It means that your answer you're going to write for O and M, for vector O and M, your answer should remain in terms of A and in terms of B. Those are the only two things that must remain. Now, what do you do always? You're going to first come and ask yourself, this is O to M. How can I obtain O to M? They have told that OM is the midpoint. Now, the first thing we are going to first obtain, in order for us to be able to calculate, we are going to first ask ourselves that O to M lies along the line O to P. So in order for us to calculate anything, we need to know the length of O to P. But since we don't know the length of OP, we are going to find it first. So I'm going to come here and first get the vector O to P. This is O, this is T, and this is P. This is O to T, which is A. This is T to P, which is B. Now, in order for me to get O to P, I'm going to come and say O and P. Now, OP means I start from O and I move towards P. But the only way I can move from O to P is using this path. O to P, I can come, I start from O, or I start from the starting point, which is O. We are going to start from here. So I can come, move like this, which is O to T. So I'm going to come and say, I'm moving from O to T. Then from O to T, here where I am now, I'm going to move to P, like that. So now I'm going to come and I say plus T to P. Now that is my movement. But when you look at the vectors, O to T has been represented by A. So here we shall put that this is A, plus T to B has been represented by B, and that is B. So that is how now we obtain our vector. Now that means that the vector O to P is A plus B. When you look at the arrows, you notice that O to T, the arrow is pointing the same direction. That's why it remained positive. When we went to T to P, the arrow was still pointing towards P, and that's why it remained positive. Hope that is very clear to everyone. Now we go to the second part. They have told that we have not yet obtained M, but M, they are telling us that, let me just draw here a line. This is where we have our O, and this is where we have our P. And they have told us that M is in the middle here. Since they have told us it is a midpoint, it divides something. It means that this is one part and this is the second part. But the total ratio from O to P, the total ratio here, you notice that the total ratio or O to P is the same as having 1 plus the 1 part, which will give us the 2 parts. That means that from O to M, O to M is equivalent. Since it has only 1 part, it is going to be 1 out of the total ratio, which is 2, of the whole line of O to P. That is O to M. Kindly let me know whether we're on the same page. We have said that O to M has 1 part of the 2 parts that make up the line O to P. Kindly, is this clear? People are saying it is clear. Very good. Now, since it is clear, we have already obtained our O to P as A plus B. So I'm going to come here and I say this is a half, then this is going to be A plus B. And that is going to be our answer for O to M. And when you look at it, we have it written in the form of A and B. That is your O to M. But I want you to pay attention to the direction, that the direction was O to M. That's why here we had it as O to P. Yes. Okay. In case, okay, that is okay. We can continue. We can continue. Okay. Now the second part is finding T to M. Now, when you are finding T to M, always join those vectors. And I want to tell you that in vectors, for whatever thing you are doing, make sure that it is visible on your vector diagram. Now, in case you find, let me say this diagram has been already drawn for you in the paper, you draw it again. You have to draw it again because that one will be squared. Draw it again such that you can be able to show the vectors that you are finding. Now, when it comes to TTM, I'm going to come here and I first join and I show clearly where T and M is. That I'm going to come here and I join that this is my T to M. And what is the direction? That we are starting from T and I'm going towards M. I will show that direction like that. So you show it on your diagram such that people can tell which direction you are taking. Now, when it comes to T and M, I'm going to ask myself that where do I start from? That we are starting from T and going towards M. Now, T to M, it means that you can take two paths. Someone may decide to come and say, let me start from T, I go towards O. Then when I reach O, that is the first vector. So I'm going to come here and I say T to M is going to be T to O. Then when I reach O, I'm going to come and move towards M. So now that means that I'm going to come here and say plus O to M. That is my second vector. Hope you notice that for everything I write, I put the arrows to show the direction. Alternatively, someone would have used this path here. Someone would have said that I can start from T, I go towards P. When I reach P, I can come and I reach my M. So that one would have been the alternative path. But since we have already obtained our O to M, this one becomes the ideal path to use. But it is okay for whatever path you use, you get the same answer. Now, when you look at T to O, can you type in the chat, what is our vector for T and O? What could be our vector for T and O? I'm looking through the chat. Aha, very good. It is negative A. Very good. Yes, because initially they told us that O to T was equal to A. And since we are opposing the direction, that means that this one is going to become a negative. So here we shall have negative A plus our O to M. And our O to M, we obtained it as a half into A plus B. That was our O to M. Now, when we reach here, you must simplify your answer. Never leave your answer when it is not simplified. If you can go on and simplify. So we are going to open our brackets. So this is going to be negative A plus, when you open, this will be a half of A plus this a half affects this, and still this a half affects the B. So we shall have a half of B. Now, you collect like terms. So that means in collecting like terms, these two are going to be added together. Now, let me just use side work. Now, as part of my side work, this is negative A plus a half of A. So what I hope everyone knows that here, there is out of 1. Meaning that your LCM here is going to be 2. So you said 2 divided by 1 is 2 times negative 8 becomes negative 2a, plus 2 divided by 2 is 1 times the other one becomes a. So here negative 2a plus a becomes negative a out of 2. Alternatively, so the whole of this part we shall have negative a out of 2 plus the b out of 2. Alternatively, someone, in case this one gives you a hard time, you say negative a plus a half of a. So you know very well that here there is a coefficient of 1. So for you can put it roughly in your calculator and say negative 1 plus a half in your calculator. That this one will give you negative a half. Then after that, you come here and add your a. That is when, in case it is disturbing you, you can do it like that in the calculator. So here, this is my simplified version, but I can simplify it further. You note that 2 and 2 is common, so I can first pull that a half out, then I remain with negative a plus b. In case you want, you can make it even much better by starting with a positive and write it as a half into b minus a. So this is your answer for T and M. I want you to look at how I'm presenting my work. Everything I'm doing it in a vertical format. So do not squeeze your work. Don't draw those short lines in your work. Always make sure that your work is presented very well in the vertical format. Okay. I hope we are on the same page. Are we on the same page? Okay. Okay, good. Okay. Okay. Should we continue? Are we good to continue now? Okay. Okay. Now we can continue. Okay. We have another one here. We have another one here. Now, the second format, all these scenarios I'm giving, all these, they're a bit direct. But when it comes to the word problems, we are going to put in the words. But you need to first understand the sketch before we go on to the other part. So when you look at our vector they have given us, always first read your question and interpret. So they have told us that OA and B is a triangle, and good enough they have drawn it for us. O to A is A, it is there. O to B is B, it has been represented, and they want us to find the vector A to B. Can I first ask everyone to try out A and B? And then you can put your answer in the chat. Let us now first try out A and B, and then we can try out. So let's first try O, A, and B and find out which answer you are obtaining. People have already obtained the answer. Jonah has obtained an answer. Virginia has obtained. Apollo, look at your direction. Your directions are not matching. Okay, Shadia, Alan. Okay. Elio. Okay, Michelle. Okay. I'm seeing the answers coming in. Very okay. Except one answer. Good. So, what are we going to do? Still, we do the same. First, write your A to B. So, A to B means we are going to start from A and move towards B. So that means I'm starting from A. This is where my A is. And then I move towards B. So to move, it means that I'm going to move from A, I come towards O, like that. So I'm going to say, I'll move from A, I go towards O. Then from O, I'll come to B. Then plus O, to B. Then the next thing I'm going to ask, what is A to O? When you notice from A to O, since we are opposing this arrow, our vector will not be A, but it will be negative A. So here we'll have negative A plus O to B. Since we are moving the same direction with the arrow, the answer will be B. So that means that this is the answer, which we can write as B minus A. So that is our A to B. Then the second part we are going to look at, so here our answer was B minus A. But I think someone has a question. Okay, he has put the hand down. Then you go to the second part. P is a point on AB so that A to P. Now here you must interpret this ratio. They are telling you that A to P has two parts. These are the parts for A and P. So that means that from A to P, you're going to put here two parts. Then P to B, you're going to put one part. So this is one part here. Okay, let me first pick the question from Joel. Yes, Joel. Patrick, you can unmute. Oh, sorry, unmute.
I wanted to ask that what if how does this contest come about of OB minus OA?
Oh, okay. Allow me to go back here. Now, are you saying from here? From
Yes,
here, you have A to B equaling to A to O plus O to B.
yes,
Are you seeing? Now,
yes,
in vectors, when I have A to O, in case I change direction and now I want to start with O to A, I always put
yes,
a negative. I say this
yes,
is negative O to A.
OA,
In case you have, let me say C to D, and you want to change to start with D, it becomes negative D to C. But these are the
yes,
same things.
yes,
Is that clear?
yes.
So A to O is the same as having negative O to A plus O to B. Fine?
Oh, okay. Yeah, okay.
So when you start with a positive, it will become O to B minus O to A.
Oh, okay.
Yes. Though I don't want you to people to cram this, because
Yes,
sometimes it will depend on the context. In some contexts, it may not work at all.
okay.
Okay. Okay. So these are our parts. Now I want everyone in the chat to tell us, what is your total ratio? What is the total ratio of A to B? What are you getting? So remember, total ratio A to B, you are adding the parts you have from A to B. So A to B, it means that you'll have the 2 plus 1, which will give us the 3 parts. Now, the key thing they have told us to find is O to P, but I want O to P. So I'm going to first draw. I've told everything you are going to find, draw it. And after drawing, you show what you are interested in, that we are interested in O to P. So I'll come here and I put the arrow, that is O to P. Then the next thing we are going to do, we are going to find out what is O to P, or which paths can we take to move from O to P. So I'll come and say O to P, that is the vector. Someone raise up the hand and tell us which path can we use to get O to P. Okay. Yes, Jonah?
Good morning, teacher.
Morning.
For my can use OA
OA, good.
plus AP.
Plus?
AP.
Now, Jonah, remember, when they tell us O to P, you must be able to stop at P, not beyond P. So
Yes, I
you
have
have reached
said
here.
AP
A,
plus AP.
oh, plus A to P. Okay, good. This is one root. Any other person with a second root that we can use? Okay, Susie.
Okay, you can use OP.
Okay, master.
Yes, Susie.
Can use OB
OB
plus BP.
plus BP. Good. Yeah. So all those parts can take us through. So any that you want is the one you use. However, I want to question you. The only things I want us to first check out is how do we obtain A to P? That is now where we are going to concentrate. How do we obtain A to P? Someone to take us through how we obtain A to P. Okay. Yes, Joel?
We can obtain A to P by first obtaining AB.
So AB, we have it already. It was B minus A.
Yes.
So AP.
AP is a half.
Now we come back there.
AB.
Okay. Thank you for trying. Now we come back. First come back before you run away. I want you to look at our line very well. Are you seeing our line?
Yes.
Look at our line very well. This is our line. A, this is P, and this is B. Now, A to P, when you look at from what they have given us, has two parts, and this one has one part. So what is your total ratio of all the parts? Yes, Joe?
3.
3. So how many parts does A to P take?
2.
2. So what would be our answer now?
2/3
Uh-huh.
AB.
2 out of 3 of the line A to B. Okay, good. Yes, so from here, friends, we shall continue and say, this is 2 out of 3, but we have already obtained our A to B as B minus A. Now, since we want to obtain O to P, now we shall come back and say O to P is equal to our O to A plus A to P. Now, I want to caution you. Whenever you are dealing with things where you can first obtain individual parts, first work out those individual parts before you combine, such that in case an error is made somewhere, you do not fail everything. An example, you are noticing that when I'm finding O to P, I know some of you can go direct. It is okay. But to avoid you losing everything in case of any mistake, you can do in parts. First find AP, such that in case this one is correct, you can be scored. But once you combine everything at a go and you make one mistake on that same line, everything will be not scored. So our O to A, since it is in the positive, this is A plus our A to P, which is 2 out of 3 of the line B minus A. So from here, we are going to open our brackets and we have A plus 2 out of 3B minus 2 out of 3 of A. Then you collect like terms. Collecting like terms, it means we shall bring the A and the minus 2 out of 3. So let me do it here as my side work. A minus 2 out of 3A. Remember there is a 1 here. So here I've told you there are two things you can do. You can just get your calc, extract this one and the minus 2, 3. So you say 1 minus 2 out of 3. For you just place it on your calculator. And then you say 1 minus 2 out of 3, get the answer. So here the answer I'm getting, it will be 1 out of 3. Then bring back the A and put here your A. Alternatively, do it the other way you know it. You say this is out of 1, get the LCM, and then continue. Alternatively, you can just cross multiply like this and say this is 3a minus 2a out of the 3. Then you remain with a out of 3. So whatever approach you want, you can use it. Yes, Mugisa, Olive?
Yes, good morning, sir.
Morning.
Sir, for my I'm confused here. From here, where we have AP equals to 3 equals to 2 over 3, then AB. That part is confusing me.
Okay. Let me first take you back here. Don't go off, eh?
Yes.
Imagine, this is our cake. Are we there?
Yes.
How many parts make up this cake?
There are 4 parts.
There are 4 parts. Now, imagine you have invited your friends, and this is maybe Mike. And I ask you, what was Michael's share? How shall we
It's
say
one
it?
out of, it's a quarter
A quarter, but of the whole what? Of the whole
of
cake.
the whole cake.
Now, similarly, when we have our line here, this is A and this is B. Not so? Now,
Yes.
if I have this one as P and this is 2 and this is maybe, let me say 1, the first thing always you get the total parts. So how many parts do we have here?
There are 3.
3. But when you look at this line of ours, what is the total length, like what is the line equaling to? Our line, the total line is called A to B. Is that fine?
Yes, fine.
So when I only obtain A to P, you notice that A to P only takes 2 parts of the whole line. So it takes 2 out of the 3 parts of the whole line, which is A to B. Are you getting? Not yet?
I'm getting, sir.
Okay, now you tell me, what if I have this? Let me say this is A, and this is B, and this is my M. This is 3, and this is 2. You tell me, what is your A to M equaling to?
My A to M
Mm,
equaling to 3 over 5,
mm.
then AB.
Then A to B. So that's how you do it.
Okay, thank you, sir.
Okay. Amala?
Yes, teacher.
Yes.
Now, I was seeing on the direction of O to B.
Mm.
You had put A,
Mm.
the vector A.
O to
May I
B.
yes, O to
Where,
B.
Amara? Let
On
me.
this other equation whereby OP,
Mm.
yes,
Mm.
I'd put A.
Mm.
Yeah, I
Where,
thought
where?
was, no, I'm saying on the second equation we had made OP is equal to OB
Mm.
plus BP.
BP. Yes, yes.
Yes. So I'm saying,
Mm.
I thought that the OB would have been what? Would have been, would have been B, the vector B plus, plus 1 out of 3 into brackets B minus A.
Oh, okay, okay. Thank you, Amara. Okay, we have not yet. What you have said is true, except that second part you have added on for that vector for B to P, the one out of the 3. That one I'm going to come and make some clarification, but that is correct. Though now we have not reached there. I think we're a bit ahead.
Oh, okay.
But we are going to come there. But you
Okay.
must get the same answer we shall obtain here as well.
Okay.
Mm. But you check out further on that second part you have added. Something is
Yes.
not adding up on what you
Okay.
have mentioned.
Okay.
Okay. Yes, Pauline?
Excuse me, teacher. Are we
Yes.
allowed to use decimal point?
Decimal points?
Yes,
No.
they must be fractions.
Yes, the best are the fractions because once you go into decimal points, you're going
Mm,
to lose out on accuracy. So always leave them as fractions.
okay, teacher.
Okay. So here we shall end up with A. You have noticed here we have ended up with A out of the 3 plus 2 out of 3 B. So in your conclusion, since 3 is common, you can say 1 out of 3 into A plus 2B. So that is the answer. Then I know there are some people who have used the other second approach. That is the one I want us to go through together. People who have gone on, this is our vector. People who have used this one, O to P is equal to O to B plus B to P. So here I want us to be very, very careful. The line we have was A, this was P, and this is our B. The direction for our line to B, this was our direction, and we obtain it as B minus A. Our line A to B, I want you to be very careful. Now, in case you are finding B to P, remember here you had the two parts, here you had the one part. In case you are finding B to P, B to P means that it is taking one part of the whole line, which has 3 parts. But since you are moving from B to P, you are opposing the direction of A and B because the initial direction was this. So here it means you are going to put, to show that you are opposing, there are two things you can do. One, either to write as negative A to B, which will equal to negative 1 out of 3AB, or alternatively someone writing 1 out of 3 of the line B to A. Since now when you are moving, you have started from B and going towards A. Kindly let me know whether that is clear in the chat. Because the moment you don't do like that, trust me, your answer is going to be totally different. Is that clear? Okay. Yes. So that one, you have to pay attention. That's why I was telling Mara, something is not adding up. So after that, this is where now you can come and say that now my B to P is going to be negative 1 out of the 3. But my A to B, I obtained it as B minus A. So when I reach here, that's when now you can open up your bracket and have negative a third of B. Now this negative here and this negative here can be added, or they can be multiplied and you get a third of A. That is what I wanted you to pay attention to. Yes, Natal.
Good morning, sir.
Morning.
I was wondering how you got the direction of AB, yet it's not given.
Oh, from our first part, Natal, we found our vector AB. Did you see it?
Yes, sir.
So the known vector A to B, we found it already as B minus A.
Yes, sir.
So that's why now I'm saying that in case you oppose it, then that means you go back like that.
Oh, okay, sir.
Alternatively, some people may use the other way around and say, let me first find B to A. Then after finding BA, then whatever you do, it will be okay.
Okay, sir.
Okay.
Thank you, sir.
Okay. Then from there, we shall say that O to P is equal to our O to B plus B to P. So here I'll have my O to B as B, then plus B to P, which is negative a third of B plus a third of A. So when you do the mathematics, this is going to be, still I've told you can extract it, you can do your side work, that this is B minus a third B. So you put on your calculator 1 minus a third. What do you get? That I get 2 out of 3 of B. So here I'll have 2 out of 3 of B plus a third of A. So when you want, you can notice that 3 and 3 is common. You can factor it as 1 out of 3. Then here remain with 2B plus A. So when you look at that answer, it is the same answer we obtained here. So hope that is very clear. Are we good to continue? Okay, let me first answer one question. Gavanian.
Good morning.
Morning.
I was asking on where you have said that OB, then BP. How does it come that there are 3 parts?
There are 3 parts.
How does it come that there are 3 parts here on the ratio?
On the ratio. From the question, are you seeing this question? From
Yes.
here, they told us that A to P has 2 parts and this one has 1 part. Are you seeing? So the total is the 3. But B and P, they take on only 1 part.
Okay.
Okay.
Thanks, Master.
Okay. Okay. I think we are good to continue. Oh no. Okay. Marita, we used the 2. We use the 2. It depends on which path you have used. So for someone who used this part of O to A and AP used 2. The person who uses the path of OB and BP uses the 1. So it depends on which path you are taking. But not all the things must work. Sometimes there are some things within the question that we may not use. Okay. Melissa? Gloria, Melissa?
Morning, teacher.
Morning.
Yes, teacher. I'm not okay. This side of the calculation that where are we? Derive the answer. OP is equal to OB plus BP. I'm not getting like the calculations. The B plus negative. I said B plus 1 out of 3.
Okay. You stay on. Melissa, are you seeing our O to B?
Yes.
O to B, we have extracted it from here. So that is the one here. Are you seeing?
Yes, teacher.
Then B to P, this one here. It is here that we had calculated and we got our final answer as this.
Yes, teacher.
So that's why we carried it here.
Yes.
Then after we did the calculations.
Oh.
Is it fine or not yet?
China also the next part, like, okay, this thing I said you put it in the calculator, then okay, I'm also not getting the out of 3B here up.
Okay, I'm saying when I collect like terms, I have this. Are you seeing? Those are the
Yes.
B's. I have
Yes.
B plus negative a third B.
Yes.
Now, when you look at this B, there is a hidden coefficient of 1 here. Are you seeing it?
Yes.
So this one here and this negative a third here, I can deal with them. Because when you look here, B and B is common. So if you want, you can say, let me first remove that vector B. So when I remove B, here I remain with 1. Here I'm going to remain with negative a third.
Yes.
So 1 minus a third, that is where we get the 2 out of the 3B. Or you can say 1 minus a third. you can say this is the same as out of 1. Then if you know this cross multiplying approach, you say this is cross multiply, you have 1 times 3 minus, since we have a minus, this will be 1 times 1, everything divided by 1 times 3. So 1 times 3 is 3, minus 1 times 1, which is 1, divided by 1 times 3, which is 3. So you end up with 2 out of 3.
Oh, okay.
Okay.
Thank you, teacher.
Okay. Then the last question, I think. Okay. Yes, Joe.
I wanted to ask that I've understood your method. But
oh, I didn't pick that.
I don't understand.
Oh, I didn't pick your question very well.
Just
okay.
AP over BPB is 2 over 1.
Okay.
Multiply.
Okay. Hamza, I think your network is not so clear.
I have understood your method. But there's another method that confuses me. Teacher.
Yes, continue.
Teacher.
Yes, others, you can be looking at that question I've displayed. Continue. Oh, he has dropped. Okay. Now, this one, you are going to try it out in your free time. You'll try it out. You can just take a screenshot. But I'm going to talk about part B, where they ask us to show the parallelism. That's where now I'm going to concentrate going forward. Okay. Have you taken a screenshot? And we continue. But part B, I'm going to talk about it. Okay, we can continue. Now, I want to first talk about what we call collinearity. Now, when they talk about collinearity in math, here they mean 1, points that lie along a straight line. Collinearity means that you are looking at, do those points lie along the same line? Do they lie along a straight line? So collinearity simply means points that lie along a straight line. Now, when you are dealing with collinearity, here the task will be show that the points lie along the same line. Show that the points lie along a straight line. That will be the task. So whenever they ask you to show that points lie along a straight line, there are 2 things that you have to base on to show that those points lie along a straight line. The 2 things you have to do, number 1, you must show that they form what you call parallel vectors. So any points that lie along a straight line, they form vectors which are parallel. That is the first condition. That for anything to be parallel, it means that it must be a scale factor of the other. An example of vectors that are parallel, take an example. If I have 1 and 2, and I have a vector 2 and 4, in case this is my vector A and this is my vector B, these 2 vectors here are parallel. Why? Because there is something you can do on A to get exactly B. Tell me in the chat, what is it that we can do on vector A to get exactly vector B? Are you noticing some digit there that you can? Very good. When you multiply by 2. What about when I have this one? I have 3, I have 6. If I have 1 and I have 2, and this is my vector A and this is my vector B, what can we do to get vector B if I have vector A? What is it that you can do? Very good, Megan. So you can divide by 3. Now, dividing by 3, here you divide by 3. Now, this division by 3 results into what you call a scale factor. When you are looking at enlargement, you looked at a scale factor. Now, this a third is what you call a scale factor. Sometimes we can call it a multiple, anything you want. Now, whenever you find two vectors whereby there is something you can do to obtain exactly the other through multiplication or division, then that means that those two vectors are parallel. Now, for anything to lie along a straight line, it must be able to form what we call parallel vectors. The second condition, so here, when you are proving parallelism, the only thing you need to look out for is there any scale factor? Is there any multiple you can multiply with one vector to obtain exactly the other vector? Then number 2, they must have a common point. They have a common point. They have a common point. For those points you are proving to be along a straight line, they must have a point that is common. Alternatively, they must pass through a common point. They pass through a common point. That's what you call for the points to be parallel. Take an example. If I have these are my 3 points. This is point A, this is point B, and this is point C. Now, for me to prove that these points lie along a straight line, one of the conditions is that they must have a common point. Number 2, they must be able to show that they are parallel. So how do we show that they are parallel? We have said that for any two vectors to be parallel, one must be a scale multiple of the other. One must be a multiple of the other. So take an example. B being in the middle here or being part of it, I can say that vector A to B is equal to K B to C. Now K is that digit that you multiply with BC to get exactly AB. For our case in the example I gave you where you have A and B, whereby A was 1 and 2 and B was 2 and 4. For this case, this was 1 and 2. And for us to get exactly this, in order for us to get exactly the other vector, you note that if I say a half of my vector 2 and 4, I'll get exactly my A. So K is that multiple, which when you multiply with BC, you get exactly A, B. Now, this is what we are going to be doing. 1, you must look out for what value is it, which when you multiply by the other one, you get exactly the other vector. Number 2, is there a common point? For this case of ours, B and B is a common point. Now, this is what you are going to be proving. Whenever they ask you, prove whether they lie along a straight line. In case I had, let me say this is P, this is Q, and this is R. To prove that they are parallel, I must look out for one common point to use. Let me say I'm going to use Q. So I'll use vector P and Q here should equal to K vector Q and R. That is what I'm going to use to prove my parallelism. You put for me in the chat quickly. What if I have M, this N, and this is O? Which vectors are you going to prove parallelism? You can type in the chat. Which vectors are you going to use? Imagine those are the 3 points they have given us, and they want to show that they lie along a straight line. A common point means that is a point that they share. That means that on both vectors you have formed, there is a letter that is the same. An example, when I looked at AB and when I look at PQ and QR, Q is common on vector QR, Q is common on vector PQ. Okay, hope that is okay, Virginia. Okay, Virginia is going to use MO and NO. MO and NO. Elizabeth is using MN and NO, that is Renata, Olive. Okay, yes, okay, okay, that is good. So we must always ensure there is a point that is the same. In case it is N, let it be N. Yes, in case for you decide to use PR, you can use PR, PQ, as long as there is a common point on whatever thing you are doing. Okay, very good. Yes, so now we can start on our first item. So I want us to first read it through and then we start. So they are telling us that we have planners that are designing a new straight load that should pass through the 3 points located at point P, Q, and R. They need to verify whether those points lie along a straight line to ensure that that load that is going to be constructed passes through them. Now they are asking, guide the planners whether they should proceed with the construction of the load. That is the first one, and that's why there is a full stop. What is the distance between the bus terminal and a shopping mall? Leave your answer in a simplified SAD. Now, the first thing they're asking you, guide the planners whether they should proceed with the construction. Now, when you look at the item, the scenario, they are looking at constructing a straight load. So constructing a straight load, that is what we say that you want to first prove whether collinearity holds. So the first thing you're going to do, you're going to first ask yourself whether those 3 points lie along a straight line. And for you to prove whether they lie along a straight line, we said you are going to prove collinearity. So that is the first thing we are going to do. So I'm going to come here and now I'm going to say, I'm working on the task. Guide the planners whether they should proceed the construction of the loads. Now I'm going to say, finding out whether the loads, whether the points P, Q, and R lie on a straight line or segment. So I'm going to come and I can even make my sketch. I can come and say this is my point P, this is my point Q, and this is my point R. Point P is given by -3. Now, these are like coordinates. So when they give you coordinates, you change them into vectors. So I'll change them as -3, -2. Q is going to be 3, 1, and R is going to be 5 and 2. So remember, P is where we have our bus terminal. This is the shopping mall, and this is the planned hospital. So what are we going to do? We have said that to prove collinearity, you are going to look out for the vectors. So here, the vectors we are going to use, you can type it in a chat, and then I see whether we're on the same page. Which vector are we going to use to prove collinearity? Mm-hmm. Okay, so we shall say PQ is equal to KQR. These are our vectors. Good. The answers we are giving are correct. Now, after doing so, here now there are two things you have to find. One, you are going to first find out what is vector PQ, and then what is vector QR. Now, what you have here, these are column vectors. But to find vector PQ, I want to tell you that now you are going to express them in terms of position vectors. Now, PQ, I want to go back and take you here. Let me just draw a sketch. This is point P and this is Q. Hope you are not seeing. Now, O is the origin, or what you call the position vector. So this is O to P and this is O to Q. Now, these are the original vectors we do have, because what you have on for the bus terminal, these are just positions. So you convert them into position vectors. So that means that your vector O to P is the one we have as -3, -2. Then O to Q is the vector we have as 3, 1. So in order for us to get P and Q, P to Q, it means that I'm going to move from P to O, then O to Q. That is P to Q. So P to Q is given by PO plus O to Q. But like I've told that when I'm moving P to O, I'm opposing the direction. So PO is the same as having negative O to P plus O to Q, which can be now OQ minus OP. So PQ, I'm going to have vector OQ minus OP. Okay, let me first pick the hand. Yes, Gavanian. The rest you can continue and be completing.
Teacher,
Yes.
I'm asking in all vectors, when we are dealing with vectors, is it that O must be the origin always?
Yes, O is the origin. More so when you are dealing with coordinates. Yes. So whenever you find a vector with O, that means it is a position vector. When you find a vector without O, those are displacement vectors. Like you find PQ is a displacement vector.
So thank you, sir.
Okay. So our O to Q for this case is 3 to 1 minus O to P, which is -3, -2. So you do your mathematics. This is going to be 3. There is a minus here, -3. Then 1 minus -2. So this will equal to 3 plus 3, which is 6. 1 plus 2, which is 3. So that is our vector PQ. Now, can I ask everyone now to first find for us QR? Let everyone now find QR, and we start from there. QR, it will be O to R minus O to Q. So let everyone first find that one, and then we continue. People are getting 2, 1, 2, 1. Okay, good. So O to R, this is 5, 2 minus O to Q, which is 3 to 1. So when you subtract, this will be 5 minus 3, 2 minus 1, which will give us a 2 and a 1. Okay, that is Q and R. Yes, Olive?
Excuse me, sir.
Yes. Yes?
How have you obtained the arrow to know that it moves from O to R, not R to O?
Oh, now when they give you a coordinate, when they give you a coordinate, are we there?
Yes, I'm there.
Yes, when they give you a coordinate, this coordinate they have given you, you can transform it into a position vector. For you to locate where -3, -2 is, okay, let me just now take you to the Cartesian plane. In order for me to place -3, -2, I always start from the origin here. -3 means I'm going to move 3 steps in the left. So I'll move 1, 2, 3. Then I'll move 2 steps down. 1, 2. So I'll place my point P here. But where did we start from? We started from the origin, like this. I don't know that you're picking the idea.
I have picked.
Yeah, so that's why we start with O going towards the other point.
Okay, thank you, sir.
Okay, now from here we are going to substitute. PQ is 6, 3. So I'll come back here and we said we had PQ, which was 6, 3, is equal to QR, which people obtained as 2, 1. I think that was it. Now, what do? When you reach here, you must show how you're obtaining K. Don't just equate and leave. So here, it means I can equate. You can say equating components. You can say maybe X components. So it means this side, I'll equate 6 equals to K times 2, which is the 2K. So I divide by 2, and my 3 is equal to 2K. Therefore, you first conclude that my PQ will equal to 3QR. Now, from here, you have not yet concluded. You are going to make a conclusion. And now it is the conclusion that I want us to make better. Because they ask you, guide the planners whether they should proceed with the construction of the load. Now, this is the task you have at hand. So you must respond, but with a reason. So now the first thing we shall say, or we can say that, since, or we can just say that PQ is equal to 3QR, therefore vectors PQ and QR are parallel and they have a common point Q, therefore they lie along a straight line. That full stop. Then from there, since they asked you, many of you do not respond back to the task. They asked us whether they should proceed. So the question was, should they proceed or no? Now you are going to continue and say that since the points PQR lie along a straight line, therefore the city planners should proceed with the construction of the road. And now that is the one that is going to earn you a mark. They will give you a mark for you to prove that they lie along a straight line. But they will give you another conclusive mark for the conclusion. AP, what you call AP, responding to the task. Because you have responded to the task, whether the planners should proceed or no. Many of you just stop at the answer here and you miss out the mark on the conclusion. So you must conclude that the planners should proceed with the construction since the points P, Q, and R lie along the straight segment. Hope that is very clear. Yes, Catherine. Yes, Catherine.
Good morning, teacher.
Morning.
Teacher, I'm confused here. Can I get QR? Like QR is equal to QO plus OR. Or it is
Yes,
always
QR equals to
QO plus OR. Or it is a must to start from O.
Wait. I'm not getting. You are saying QR is equal to QO.
QR, yeah, QO plus OR. Can I do it that way? Or it
Yes.
is a...
Now, this is what you are doing in case it is vector. To get QR, you have gone to QO, then you went to OR. It is very okay.
Okay.
But do not forget that when you reach QO, you'll put a negative there for your point. of R, of Q as 1. Yes, then you continue the OR, which was 2. So it is okay.
Okay, thank you, teacher.
Okay. Okay, then we go to the second part of the question. So hope you have had the conclusion. The second part, what is the distance between the bus terminal and the shopping mall? Now here, they are testing you whether you know how to obtain the magnitude. That is what they are asking for. Do you know how to obtain the magnitude? That's what they were asking for. Whenever they tell you distance, distance means the length between the 2 points. So when you look at our length, we have the bus terminal, which is at point P, and then we have the shopping mall, which is at the distance Q. PQ. So the good thing, we have already obtained our PQ. So our PQ, we add our answers 6, 3. That was our PQ. So that is where we are going to start from. So allow me to first create some slide here. So we had our we had our thing PQ. We had it as 6, 3. Now, whenever they tell you to find the distance, sometimes we can call it the length in vectors. Always we just get the square root of x squared plus y squared, whereby x is the x component, y is the y component. So the length, sometimes in case they use size, magnitude, you just come and say, this is the square root of 6 cubed plus 3. Sorry, this is squared. 6 squared plus 3 squared. From here that we had our P to Q was 6, 3. So from here, I'll come and I say, my 6 squared is 36 plus 3 squared, which is 9. Then after, you add 36 plus 9, which would be root of 45. Then they asked you that, they told that leave your answer in a simplified SAD. Now, our answer here is not simplified. I understand some of your calculators can do it quickly. Some of your calculators may not be able to give it to you quickly. So, what do you do? Because they told to leave it in SADs, okay, AM, I'm going to respond. So what do you do here? Now, when you have a digit, let me say 45, and you want to write it in a SAD, you are going to first ask yourself, what are the perfect squares that give us a complete SAD? So you know you have 1, you have 4, you have 9, you have 16, you have 25, you have 36, and so on. Now you ask yourself, what you do always, you get these perfect squares here. You keep dividing them by that digit. Let me say you say 45 divided by 1, which is 45. Then you say 45 divided by 4, 45 divided by 9, 45 divided by 16, and so on, until you come up with one that doesn't give you a point. So 45 divided by 4 is a point. This one is going to be out. 45 divided by 9, this one, 45 divided by 9, this one gives us 5. This one gives us a point. You remove it. That means that the best combination you are going to deal with is going to be this. So that means that 45 is the same as having 9 times 5. And already 9 times 5, that is 45. Now, when you are writing, the first digit you write, let it be the one which has a perfect square. Then the second one, let it be that digit without a square. Hope that is okay. The first one is the one with the perfect square. The second is done without a perfect square. So when you separate, this will be root of 9 times root of 5. So this will give us 3 root of 5. Now, in case they have given you units, you put. In case they don't put, then you can just say 3.3 units. Then you end there. Okay, so I'm going to look through the chart. So teacher, if it is QR you are looking for, and you are subtracting it. So here, my conclusion here, it will just be what is the distance between the bus terminal and the shopping mall. So I will conclude and say the distance between the bus terminal and the shopping mall is 3√5 units. That's how I can conclude on that. Do not forget to conclude that 1 mark. You may find yourself losing out 1 mark on each item you are doing. And at the end of the day, that would be a lot that you would have lost. Okay, AM, for your question, I don't know whether I was able to explain, but when you are getting QR, it means we are starting from Q, going towards O, and then going towards R. So, since we are starting from Q, it means Q to O is going to be negative OQ. So that's why we always start with OR minus OQ. Okay, I think now we are good to continue. Now we continue to the next part. This is a scenario. Now you have noticed, number one, these scenarios they give you, they can combine different topics. And this scenario was the scenario in Wakissha. This was the number in Wakissha. So you notice that they combined business math and they combined it with the vectors. The first part of the question was involving business math. The second part was completely vectors. And when you look at this vector, they did not draw for you the diagram. And which things were they asking for? When you read it through, you are noticing that they were testing. Do you know how to deal with collinearity? That was the first thing they looked at. Then from there, they went on and said, placed in the middle. Do you know how to deal with midpoints? So that is what we are going to be dealing with. So we are going to first do the first part and then we go to the second part. Okay, this is our question that we are dealing with. Let me hope it is still clear here. So we are going to start. Let me hope you can be able to see it clearly here as well. Now they are telling us that Francis deals in buying. Now, people, I want us to pay attention to the presentation of your work. Francis deals in buying and selling of land. He has a plot of land on sale. Ugandan shillings 15 million cash. However, he also sells it at higher purchase by accepting a deposit of 60% of the cash price and then pays this per month for a year. Zula does not have cash and she wants to buy this plot, but she's not sure of the total amount she will pay for it. Now here, our problem, you need to identify what is the problem in the scenario because that's what you are solving. Our problem here in the scenario is that this person that is interested in buying the piece of land doesn't know how much she's going to pay. So this question is testing your knowledge of installments. Do you know how to deal with hire purchase? Because it is through hire purchase that, so here the question will not tell you calculate the hire purchase, calculate this and this, but you as an individual, you need to know how to calculate it. Hire purchase is paying in installments, paying in bits. You are not in position to pay at once, but you can be able to afford the same service through paying in small bits. That's what Zula wants to do. So your task, when you are responding back to the task, you must be able to point that the problem has been solved and you have been able to find out how much Zula must pay for that particular piece of land. So we are going to come here and say, now we are attempting part A, the total amount that Zula will pay for that plot. Now you'll come and say that to obtain the total amount is going to be the initial deposit. Initial deposit plus the total installments. That is the first thing you're going to deal with. Now, when you are calculating, to avoid losing marks at once, I've told you that for anything that involves two different parts, first work them out in parts or partially before you combine your total answer. So I'm going to come here and say calculating initial deposit. So I'll come here and say that initial deposit was 60%. So I'll come and say 60% times the 15 million. I'll come here and say, you notice they use UGX, stick to UGX. I'll say UGX, and then I make my multiplication. So this one will give us 9 million. That is the first one. Then after that, I go to total installments. Then I'll come and say installments. Hope you are noticing how I'm presenting my work. I'm presenting it in a vertical form, not side by side. Avoid presenting your work side by side. Present everything in. Then I know very well that in a year, because he wants to pay it per month for a year has 12 months. So I will say that installments will equal to the amount is supposed to pay per month or monthly, the monthly pay times the number of months within a year. So this will be 815000, then times the 12. Then I'll come here and I get my amount, which will be now, since here they use shillings, then I'll come and say shillings. This is going to be 9780000. Then from here, that's when now I can go and calculate my total installments or my total amount. So I will say now total amount will equal to, since I said is equal to initial deposit, so I will say is equal to 9 million plus the 9780000. So this one will give us a total amount of 18,780,000. So I can put here, since the total amount is supposed to pay must be in UGX. So I'll say here UGX 18,780,000. But here you have obtained your answer, but you have not made a conclusion. So you're going to make a conclusion and say that the total amount of money that Zula will pay for the plot of land is 18,780,000 Ugandan shillings. So that response, you are responding back to the question. So when you just stop here, you need to write to make that response that the total amount Zula will pay for the plot of land is Uganda shillings this. Then you place this. Put it in figures because some of us have challenges with writing in words. So put it in figures. So you'll get a mark for the response or responding back to the item. Oh, people are saying the work is... Okay, let me first pick this one. Yes, Rena?
You're not seeing the calculations.
You're not seeing the calculation?
Yes.
Oh, people, let me know in the chat whether if you are not seeing. Yes, Jelly, let me first ask people whether they are seeing. People, let me know in the chat whether you are able to see. Jelly? Morning.
My question is, what if they don't give you the number of installments and they only give you the amount to be paid per installment? So what do you do then?
If they give you the total amount to be paid and they have not given you the amount to be paid per installment.
The number of installments. but they give you the amount to be paid per installment.
Okay, if they give you Jerry, come again, you are not clear.
As if they give you the amount to be paid per installment, but they don't give you what's the number of installments.
Oh, then that means for that
For
one, it
example,
may be hard for you to continue. But always there will be a hint in case they do not mention it directly that the number of installments is this. Take an example now for this question. It was there is something that was hidden from you. So you had to know that since they said for a year, then you need to know in a year we have 12 months. So there will always be a hint within the question to enable you to proceed. Sometimes they can say for 5 installments, for 10 installments, or for 2 years. Now you need to know that if it is 2 years, then it is this. That those are 24 months.
all right.
Okay. So I don't know whether Rena, you are able to see the work. Because people in the chat are able to see it. Okay. Now we continue to the second part. We continue to the second part. Now the second part wanted us, I come to the second part. They told us that David hires a surveyor to make the boundaries. The surveyor sets points P, Q, and R such that point PQ is this, point PR is this. Points S and T are midpoints. Now, you keep taking note of those midpoints of PQ and QR respectively. A point U is placed on SR such that this one happens. David wants to know if points P are collinear to approve the surveyor's work. Now, what are you going to do? Whenever it comes to this element of construct of geometry and measures, having a sketch is important. Make sure you draw a sketch where you see it is necessary. Take an example for this number. You must come up with a sketch. That sketch you come up with that you are going to use to make your calculations, it is going to be given a mark. So come up with a sketch, be it bearing, be it circumscribing, inscribing, always come up with that sketch. Come up with a sketch. For actual diagrams, you go on and do the actual diagrams. Never forget to draw a sketch. Be it even when it comes on pyramids, it has come on cylinders and other figures. Come up with a working sketch. Don't just start making calculations without having those sketches. Those sketches count a lot. May I ask everyone to first come up with a rough sketch of this situation? Okay, I get, sorry. Okay, I get. Okay, thank you. I was doing something different. Okay, but let me duplicate, and I'm going to ask you let me change it like this, and I first ask you to come up with a sketch. Everyone, come up with your own sketch. First, come up with a sketch. Yes. Come up with a sketch. Let me first, I don't know. Okay, I think this is the one. Come up with a sketch, and then we are going to continue. I think this is the one. Okay, so come up with a sketch. Okay, thank you, Maria. Okay. I'm back to Wakissha, I think. This is the Wakissha thing, right? You can let me know in the chat. Is this Wakissha now? I think so. Okay. I want us to first come up with a simple sketch, everyone. First come up with your rough sketch before we continue. After making your sketch, you let me know in the chat that we have finished. So the second paragraph is the one we are working on. Okay. Okay, and hope my screen is on. Okay, I'm going to take an assumption that at least everyone has come up with a simple sketch, and you'll indicate there maybe a sketch, a vector diagram, something like that. That is okay, Mara. Okay. Good, good, good. Okay, I think I've seen Mara has posted here a sketch, and now we can continue and start. Okay, now I'm going also to come up with mine, but don't mind, in case your sketch doesn't look like mine, it is okay. Okay, then I'm going to say a vector, I'm going to say a sketch showing the land boundaries. That is going to be just my simple title. Then since they told us it is a triangular form, now you need to pay attention. It can be a triangular in nature. It can be a parallelogram in nature. It can be a rectangle in nature. So you need to check out which kind of shape are they dealing with. So that one is going to be important. Yeah, so you need to know which. So now I'm going to come up with my simple sketch as well. And being vectors, I encourage use a ruler. Use the ruler such that you come up with straight edges to indicate the vectors. So they told that the mark points, 3 points. So this one is going to be my O, this one is going to be my A, and this is going to be my B. Then they told that O to A, now you put the arrow to show the direction, and it has been given as A. O to B, put the arrow to show the direction that this is now B. Then from there, points C and D are placed in the middle of OA and AB respectively, meaning that OA goes with C. So I'll come here in the middle, I put point C. Then D is along AB. So this is the AB, and I'm going to come here and I put my point D. It's also in the middle of A to B. Another point E is to be marked on BC. Now you join B to C. So I'm going to come here and I join B to C like that. That is my point B to C. And they have told us they have placed there a point E. Let me say this is my point E. Such that B to E is 2/3 of BC. Now that one is very important in order for you to know how many parts. So I'm going to first come and say B to E is equal to 2 out of the 3 parts of B and C. Now there are 2 ways you can do this number. One, I can first remove BC and I take it this side by doing divide by BC, divide by BC, such that I have B to E out of B to C is equal to 2 out of 3. Now this in a ratio form means that B to E to B to C will equal to 2 to 3. Meaning that from B to E, you have 2 parts. B to E, you have 2 parts. Then from B to C, you have 3 parts. That means that the whole of this blue line I've drawn has 3 parts. So that means you need to know from here, this is where I have my C. From C to E, how many parts shall we have? Members in the chat, quickly. How many parts are you going to have there? Or what have you put there? Aha, very good, Megan. 1, Abraham, good, 1. So here we are going to just put that this is 1 part. Since the whole of this line has 3 parts. Now, in case you don't approach it in this format here, in case this is not the way you want to approach it, you could as well interpret it in this form that B to E is 2 out of the 3 parts of BC. Now, you can remove this 3 and write this as 3BE is equal to 2BC. Now, what does it mean? When I have these 3 parts here belong to BC. That means that from B to C, you have 3 parts. These 2 parts here you have here belong to B and E. So that means that from B to E, you have 2 parts. So you can also interpret it in that format. So any way you want is the way you interpret it. Now, this is the working sketch we do have. And now from here, you can proceed and find other parts. Now, the first part we are going to find is going to be E. And you will notice that in vectors, many times we give you an order. You can look at and follow that. So that order will help you. But the only problem with the vectors, once you fail one part, you may find that it has made you fail the rest of the parts. So that means when you are doing them, you must be very careful not to make any errors. Now we are going to go and start with our sketch here. Now we want to find B to E. But in order for us to find B and E, we cannot be able to obtain B and E minus us knowing what is B to C. And also, after knowing that, we need to move from there. What is B to C? That is the first thing we need to find out. But we cannot know B to C minus us knowing what is O to C. So there are quite a lot of things we are going to first work out. So I'm going to come here and use this space to do it. So I'm going to come up still. Just allow me to come up with this sketch again, whereby I have O, I have A, I have B. So here they have told us it is B. This is our A, and we had our C here, and we had our line here, where we had here our E, and we had here our point D. So they told us that C is the midpoint, meaning this one is 1 part, this is 1 part. But for us to be able to find B to C, we need O to C. For us to find OC, we need to know. Now, 1, when you look at our line, this is O, this is C, and this is A. They have told us that this C is the midpoint. This is 1 part, and this is 1 part. Meaning that O to C will be equaling to, who can tell us in the chat, what is your O to C? O to C now, we are finding O to C. What is OC equaling to? I want now to first express our vector. OC in terms of A. When you look at OC, how many parts? Very good. Good, Pauline. Very good. 1 out of 2. Very good. So OC is 1 part out of the 2 parts of our line O to A. But O to A is given by a half of A. Now that is the first thing. Now, why are we doing this? Because when you look at our question, they wanted us to find BE. But BE, to find it, there is one of the roots here that BE is 2/3 of BC, but we don't have BC. So now we are going to come back and now find what is our B to C. Now B to C, this is B to C. Can someone raise up the hand and maybe you take us through how to find BC? Now I want us to find BC. How do we get BC? Yes, Gloria?
So I think BC is going to be equal to BO followed by OC.
BO plus O to C. Very good. What is our B to O?
Negative B.
Negative B plus what is O to C?
A half A.
A half of A. Very good. So that is our B to C. And those who want, you can write it as a half of A minus B. That is also very okay. Then from there, we are going to go back to finding B and E. So from our question, we notice that BE has two parts here and this has one part. So we know that B to E is given by two parts out of the total three parts of the line B and C. So now we are going to go and substitute what our BC is. So this will be 2 out of 3. Then I'm going to put this. BC is given by 1 out of 2A minus B. Those are the parts. Now, when I want, I'm going now to simplify. I'm going to open the brackets. So when I open, this will be 2 out of the 3 times a half of A minus, remember these 2/3 affects everything, 2 out of 3 of B. So this 2 and the 2 will cancel. I don't want to cancel it, but just to show you, these 2 are going to go. So here you remain with A out of the 3 minus 2 out of the 3 of the B, of which now someone can write it in another way as 1 out of 3, since 3 is the same, into A minus 2B. But in case this one is giving you hard time, for you stop there. It is very okay. Though now when you write it in this format, it will help you at the end when you are dealing with collinearity. How was... Oh, I don't know whether AM was obtained how we got the half A. A half A, because this line has two parts, but O to C only takes one part of all the two parts. So that's why we said a half of the whole line of A. Then when we go to the second part, they wanted us to obtain O to E. So I'm going to come here and now obtain what is O to E. Now, when I'm getting O to E, I'm going to come and say my O to E, my vector OE. Now, like I've told you, go back on your sketch and indicate O to E. Now we are finding vector OE. This is our vector O to E. O to E. Then I'm going to ask, which paths can I use? Can someone raise the hand and you tell us how can we get O to E? O to E. Oh, Michelle? Okay,
Okay, sir.
Okay.
O to E is equal to OB then plus EB or BE
plus B to E. Very good. What is our O to B?
Our O to B is B.
Plus B to E.
Our B to E is this one where we have a half of 3, then into A.
Okay, good. Okay, yes. So this is our B to E from here. So when I reach here, we shall collect like terms, B minus 2/3 of B, then plus A out of the 3. Then now you collect like terms, B minus 2/3 B. So I told you can do your side work and say B minus 2 out of 3. So this is 3B minus 2B out of the 3, which gives you B out of 3. Alternatively, you can just say 1 minus 2 out of 3. So from here, you'll notice that you are going to obtain B out of 3 plus A out of 3. And if you simplify, this one can be a third into B plus A. That is your O to E. Hoping we are on the same page. Okay, Alternatively, yes. Okay, yeah. Those parts are very correct, Renata. So we can go to the third part. The third part wants us to find B to D. B to D. B to D is here. Now, to find B to D, you can look out for the best path also to use. I remember also they told that B to D was in the middle. So it was one part, one part. So I don't know who is going to give us B to D. Yes, Gloria?
Teacher, sorry to take you back, but
Okay.
I'm asking a question about OE.
Which one?
OE.
OE. Yes.
Yes, now if you're going to get BE, does it mean that, okay, remember here we got a third into A minus 2B. Does it mean you're going to eliminate the third and give A and 2B like a denominator as 3?
Oh, okay. At this step here, are you talking about this step here? Am I losing her? Yes, Gloria.
Yes, teacher.
Hey, now that step, I just opened up the brackets here. But it was also very okay for you to say a third A minus 2B. Then after you open the brackets again to get to this.
Oh, okay. Thank you, teacher.
Okay. Okay. Yes, Pauline?
Teacher, may I want to give the answer of the next part?
Okay. You are taking us through BD?
Yes. So for
Okay.
BD, we are going to say a half. BD is a half AB.
BD is a half
A
of
half AB.
A and B.
B. Yes.
It is a half of
AB.
Now, before Pauline, you go away. Now, Pauline, are you
Yes,
seeing
teacher.
B? Now here, it means you are starting from B, moving towards D, right?
Yes.
So, it means you must start from here and you go like this, right?
Yes.
But now the direction you have given us starts from A and you come towards B. You are starting from up here and coming downwards. So there is something you need to look at, more so in the direction.
So I think it's supposed to be a half BA.
A half of?
BA.
Perfect. Now that is the best. If you had tried like this, it would have been negative, like that. If you had write that first one, that second one you gave us, that is the best. A half of
BA.
B and A, such that this first letter matches with this vector.
Okay.
Okay. Are you taking us again to find AB? Okay, allow me to first create some space here. Okay. Okay. Pauline, are you taking us? We want now to find AB.
Okay. So we shall say?
Yes.
BO plus
BO
plus OA.
Okay, let me first speak. So you're saying A to B, or you're finding BA. Which one are you finding?
I'm finding BA.
Okay. BA you have said is equal to?
OB.
Now, can you move us very well? When we are finding BA, where do we start from?
We start from B.
We go to? Remember, you want to reach A. So we can move from B to?
To O, then from O to A.
Very good.
So
So
we shall say BO
BO
plus OB
or
plus
BOO?
OA.
OA,
OA.
good.
Then BO is B.
BO, look at the direction, Pauline.
Negative B.
Negative B.
Plus A.
Plus A, good.
That will give us A minus B.
Which is A minus B.
Minus
Okay.
B.
Can we go back to BD now?
Yes. BD is going to be a half of BA. Shall say a half into A minus B. Then it will be A out of 2.
Okay. If you want, okay, no problem. If you want to write it like this.
Minus B out of 2. Yes.
Okay. Okay. Perfect. Thank you. Let me hope that is the answer everyone is getting. OB plus BE. Okay. In case that's not the answer, you can let us know, but that is the answer I expect. Yes, Alan.
Good morning.
For
me, I've tried it in a different way. First found D, then tried out BD.
You first found out?
D.
D. Take us through. What did you do?
OD is equal to a half OA plus OB.
I beg your pardon? OD
is equal to a half OA.
A half?
OA.
Now,
plus OB. Plus OB.
Plus OB.
B.
I'm still trying to say O to D. Isn't this O to D?
Yes.
So you are saying is equal to a half of. I'm not seeing the root you are using. Which roots are you using? Because, Alan, you must have a root. To find OD, I'm not seeing where you're getting a half of OA. Because a half of A is here.
Yes.
So, maybe the other alternative would have been, if you wanted OD, to come O to A, then A to D. Alternatively, it can be O to B, B to D. Those are the simple roots you could use. So this statement here has some few challenges. Much as OB is okay, but this I have OA, because OB you can move like this and then you come back to BD.
Okay, sir.
So you check out that. Okay. So we have found BD, and now the last part they're asking us to show should Francis pay the surveyor? Now, the problem in the question was, remember you look out for the problem. What is the problem? The problem, Francis was not sure whether the lines were on a straight line. So he wanted to be very sure. Those people, when you meet surveyors, sometimes even people, when they are working on roads, usually see people holding some kind of like a mast. It looks like this. Someone stands from a distance and then starts looking through. So he's trying to find out whether things are along a straight line. So Francis wants to find out whether they are surely along a straight line. But which points are they? Is he looking at? Whether O, E, and D are along a straight line. So I'm going to come here, and then you can first come and say, this is my O, this is my E, and this is my D. Then you need to look out for which vectors are you going to use. So, Renata, so you ask which vectors are you going to use. So who's giving us, who's taking us through how we are going to find that vector? I want us to first identify the vectors we are going to use to show that they lie along a straight line, and then we continue. Anyone who wants to try? We want to show that they lie along a straight line. So which vectors are you using? Okay, so to show that they lie along a straight line, we can use O to E is equal to K, E, D. So we are trying to prove whether they lie along a straight line. So the other first thing we did, okay, yes. Now you ask yourself, do we have vector O to E? I can first go back a bit and check whether we have O to E. Good. O to E, we have it here. Then the second one is E to D, whether we have vector E to D. E to D, unfortunately, we don't have it. So we have to find ED. Since we have OE already, so I'm going to find out our vector E to D. Now, when you look at our vector E to D, from here, you notice that this is our vector when I continue joining E to D. So you notice that E to D can be our vector. E to D, I can decide to use E to B, B to D. Hope you are noticing that route. I can say E to B plus B to D. Another person can decide to use E to C, C to A, A to D. You get the same answer. Another person can decide to say, I want E to O, O to B, B to D. You get the same answer. As long as those vectors you are using add up, you'll always get the same answer. I've said there are three paths you can use. Someone may decide to use this. Another person can decide to say E to C plus C to A plus A to D. That one is also okay. Another person can decide to say E to O plus O to B plus B to D. As long as you follow the right path that moves you from one starting point to the ending point. Whatever route you use, you get the same answer. But me, I want to use this easy route here. Since I have already my EB and I have my B to D, so it will be a bit easy. So ED, we have said we are going to use E to B plus, where is that thing? E to B plus B to D plus B to D. So my E to B, I think I have it already. But what do we have? We obtain B to E. So mean that to get this one we want, since we have already B to E, to get E to B, it is going to be the negative. So EB is the same as the negative of B to E, then plus B to D. So since I have BE, I will just put negative. Then I go back and I check out what was my B to E. B to E was a third A minus 2B. So this is going to be a third A minus 2B plus my B to D, which is here, which is A out of 2 minus B out of 2. Kindly let me know through the chat whether we are still on the same page. Are we still on the same page? Okay, good. So I'm going to open up my bracket here. So this negative will affect, so it becomes negative a third. into A minus 2B plus the A out of 2 minus B out of 2. When I open further, it will be negative a third of A. Negative times the negative, I'll get a positive. So it will be 2B out of 3 plus A out of 2 minus B out of 2. Now, when you reach there, collect like terms. Bring the A's together, bring the B's together. So this will be negative a third A plus A out of 2 plus 2 out of 3B minus B out of 2. Now, this is where the mathematics has to come in, collecting like terms. So you can do your side work in case you are not sure. Like I said, negative a third of A plus A out of 2. For you can say this is the same as like negative a third plus a half. But everything I have to multiply by A. Do not fail to use the calc. Use the calc. Put it there in case the addition is disturbing you. So here you notice we shall have A out of 6. Do the same to the other one. Say 2 out of 3B minus B out of 2. Then you say this is 2 out of 3 minus 1 out of 2. Everything into B. So you put in your calc 2 out of 3 minus 1 out of 2. So then put on your calc. Still this will be B out of 6. Hope that is okay. So meaning that we are going to remain with something like, here I'm going to remain with A out of 6 plus B out of 6. And since 6 is a common factor, I can remove it. If I don't want, it is also okay. So someone can just write this as 1 out of 6, A plus B, if you wish. If you don't wish, it is also very okay. Are we still on the same page or we are leaving some people behind? Okay, let me first pick some hand. Yes, Talemwa James. Talemwa. James? James? Okay. I'm failing to get James. Okay. Now, from here, what am I going to do? Remember, I must prove. So I'm going to come back here to this original statement we made and say O to E is equal to K E to D. But what was our O to E? When you go back, your O to E, what is O to E? Was a third B plus A. So I'll come here and say this was a third of B plus A. And here we are getting K into 1 out of 6 into A plus B. Now here always feel free to find K. It is up to you. You can decide to equate the B's or the A's alone. Alternatively, you can equate at once. There is no problem. So in case you want, you can say this is a third of B and I'm equating it to this side with a vector K out of 6 of B as well. That is one alternative. Another alternative someone can do can say, this is a third B plus A. This side I have K out of 6 B plus A. So since these two vectors are the same, then I can have this and this equated. Alternatively, get an individual vector B and B. So in case I equate individual vectors, since they're in the same direction, B and B, it means I remain with 1 out of 3 is equal to 1 out of 6 of K. Then when you do your mathematics here, allow me to do my rough mathematics here. So I can cross multiply. I have 6 is equal to 3K. Divide by 3, divide by 3, and K will equal to 6 divided by 3, that is 2. So I'll end up with a 2. So that is what you can do. So I'll come here and say, my K now, I've obtained it as 2, and therefore I'll have O to E is equal to 2 E to D. Now that is now that I've proved that there is some parallelism. Then I go back to the question to respond. Remember, you have not yet responded to the question. The question was asking, should Mr. Francis pay? And what are the conditions for Mr. Francis to pay? The points must lie along a straight line. They must be collinear. So here in your conclusion, after finding the collinearity, you are going to come and say that since OE is equal to 2ED, then remember collinearity, we say that the two things you need to mention, because you have to prove their collinearity. One is parallelism, that they are parallel, and two, they have a common point. That is your evidence. So you're going to say, since OE is equal to 2ED, then vector OE is parallel to ED, and also they have a common point E, or you say, or they pass through a point E. Therefore, Mr. Francis should pay the surveyors since the points are collinear. You conclude. So your response that he should pay must be backed up with evidence. In case you start by saying that Mr. Francis should pay the surveyors because the points are collinear. This is because, or this is observed because, maybe this is observed or seen by having point vector OE being parallel to ED and a common point of E, something like that. But do not forget the 3 points you need to mention in your conclusion. That one, should he pay or not? If he's to pay, why? And if he's not to pay, why? So for him, the condition was they are collinear. So why are they collinear? You look at the parallelism, you look at the common point. That there is a common point and there's a common point and they are parallel. What has proved that they are parallel? There is a scale multiple. There is a factor which when you multiply by another vector, you get exactly the other vector. Kindly let me know whether we are on the same page. Are we on the same page? Okay. I think we are on the same page. So what is going to be your task? I want to leave you with a similar task that you are going to try out in your free time. So you can, it is almost the same, but I want you to try it and see whether you can be able to get the answers. So you can take a screenshot. You can take a screenshot. When you finish, you let me know. Okay, I think people have finished. Okay, let me first check on just some questions. Yes, Gloria?
Which I'm kindly requesting for the last slide that had the part for proving.
Okay. Another time when they tell you that they lie along a straight line, please you do the needful. So when they say they lie along the same line, prove that they are on a straight load, like that. So I've told you collinearity means straight line, means yes. So they can, in case they use another word, do not get confused. It means the same thing. Okay. Wakissha.
Yes, excuse me, sir. I'm
Yes,
asking
please.
for a right time when you are going to be ending this lesson.
Oh, okay. I think the lesson has ended. We shall stop here. Then tomorrow, we shall look at transformations, matrix transformation. That is tomorrow. So every day we shall be looking at a new topic. And if time allows, starting today, I'll be uploading at least 3 to 5 items for the different mocks with their solutions. I'm going to get time and I do at least 3 to 5 items, and you'll be finding them every day up to when I go for some official duties. Okay, so when you get them, you also continue the practice. But this video will be uploaded today before 10. Okay, thank you so much for attending. Have a lovely day. Let's meet tomorrow, but also let's meet today at 2 p.m. For the physics lesson. Bye bye.